Hello and welcome to section 3.6, compound inequalities. Lauren is in a marshmallow eating contest. In each minute, twice what she eats plus 3 is between 21 and 63 marshmallows. Write in inequality, then solve and graph it. We're going to explore this problem as we try to figure out how to solve and simplify compound inequality. Okay, let's set up our notes. So right now what I'd like you to do is put the title. Title is compound inequalities. Our essential question is, how do inequalities relate to equations? And today is the 28th, but you can write this down the date of whenever you decide to do this. This set of notes will go in our interactive notebook. And actually, if you would like, there was something on the screen. That's why that moved just then. Sorry about that. You can put this in your interactive notebook. This could go under page, I will look, 19 for compound inequalities. So, we know some things about Lauren and her marshmallow eating contest, and we can use this word twice to translate to twice what she eats. So we don't know what she eats, that's why that is the x. Twice that is 2 times that. Obviously the plus 3 part comes in here. But next, this other part says it's between 21 and 63. So the way we deal with it is we literally put it between 21 and 63 to show that this quantity is between those two numbers. So now we need to write this as an inequality. Well, the way you do that, we can see that 2x plus 3 has to be greater than 21, and it has to be less than 63. Since this is a combination of two inequalities, it is called a compound inequality. So, in order to solve this compound inequality, we would do exactly what we would do if this were a regular inequality. If I was just looking at, say, the right portion of this that says 2x plus 3 is less than 63, I would subtract 3 from this side of the inequality and subtract 3 from this side of the inequality. The only difference is now we're also going to subtract 3 from the other side of the inequality. I'm going to draw my lines because we are still having a variable party. This is a huge variable party with variables and numbers everywhere. So if I subtract 3 from 21, I get 18. Subtract 3 from here is a hua. And we get 2x. And just bringing down the signs. And 63 minus 3 is 60. X is not by itself, so we're not yet done. So I'm going to do the opposite. The opposite of multiplying by 2 would be dividing by 2. Whatever we do on one side, we have to do to the other side. This is a hua. And we get x is less than 60 divided by 2 is 30. And we get x is greater than 18 divided by 2 is 9. In a compound inequality, that's what it looks like. If we were to graph that, I'm just going to remind that we had 9 and 30 as our answer. So I'm going to add 0 because it's always good to put 0 as an orientation point on a number line. There's 9 and there's 30. Now x is less than 30, so we're going to start with an open circle and we are going to shade to the left. X is also greater than 9, so that's an open circle. We need to shade to the right, and the answer to this problem is all these numbers that are overlapped, that where the arrows overlap or that they have in common. So what we need to talk about right now is problems with and versus or. The last example we did was an example of an and. So say there's some graph where we have numbers that are less than 2, which would shade this way, and greater than or equal to, say, 1. Just making these numbers up. So closed circle, I'm going to color that in, and it's harder to color than it looks on this program. So we shade this way, and it's where they overlapped. That's an example of an and. We also have examples of or that in general look a little different. The or example, let's say we had x is less than 1. I'll stick with the less than or equal to, so shade that in. Less than or equal to 1, we would shade to the left. If we have x is greater than 2, or so this is x is less than 1, less than or equal to 1, or x is greater than 2. Now a number can't be both less than or equal to 1 and greater than 2 at the same time, so that's why we have to have this or statement in the middle. And in general, the ors look like this, where they're pointing in opposite directions. So notice the difference. The and, the solution to these are in the middle because they satisfy both conditions, versus the or, you can't satisfy both conditions, so they point in opposite directions. In general, that's what ors look like.